Muli pong nagbabalik ang DepEd Hour sa ikalawang set ng instructional videos na tatampukan ng dalawang video lesson mula sa Araling Mathematics. Halina po, makinig at matuto sa ating Tele-Turuan.
Good day to our dear televiewers and listeners. This is Diane Cabiltes of JP Melencio Memorial Elementary School, your teacher presenter for today's episode of DepEd Hour Tele-Turuan. Our lesson for today is identifying common factors, greatest common factors, common multiples, and least common multiples. Last time, we talked about prime and composite numbers. Let me see if you still remember our past lesson. What are prime numbers? Prime numbers or primes are numbers with exactly two factors, 1 and the number itself. How about composite numbers? Composite numbers are numbers with more than two factors. Let us see how much you have learned from our past lesson. Let's have a short drill. Tell whether the number is a prime number or a composite number. 12. 12 is a composite number. 13. 13 is a prime number. 25. 25 is a composite number. 23. 23 is a prime number. 21. 21 is a composite number. Very good. That's all for our drill. Let us start the lesson with a word problem. Read with me. Rose helps her mother in their store. Last Saturday, her mother bought 20 pieces of face shields and 50 pieces of face masks. Her mother asked her to repack these face masks and face shields. How many packs can she make if she wants to put the highest possible number of face masks and face shields in a pack without any excess? Let us first analyze the problem. What is asked in the problem? The number of packs she can make if she wants to put the highest possible number of face masks and face shields in a pack without any excess. What are the given? 50 face masks and 20 face shields. What is the strategy to be used? We can solve this problem using any of the three methods. The first one is the listing method. We have 3 steps in this method. Step 1, list all the factors of the numbers. 20. The factors of 20 are 1, 2, 4, 5, 10, and 20. 50. The factors of 50 are 1, 2, 5, 10, 25, and 15. Step 2. Identify the common factors. We have 1, 2, 5, and 10. So the common factors are 1, 2, 5, and 10. Step 3. Identify the greatest common factor among the common factors. From the common factors 1, 2, 5, and 10, 10 has the greatest value. Therefore, the greatest common factor or GCF is equal to 10. The answer to the problem is 10 packs. The second method that you can use to solve the problem is the prime factorization, where you can use the factor 3. Step 1. Find a pair of factors whose product is the number we are factoring. For 20, we have 2 times 10. For 50, we have 5 times 10. Step 2. Continue factoring until all the factors at the bottom of the tree are prime numbers. For 10, we have 2 times 5. So, 20 is equal to 2 times 2 times 5. For 50, we have 50 is equal to 2 times 5 times 5. We will not use the other prime factor 2 of 20 because it does not have a pair with the prime factors of 50. And we cannot use the other prime factor 5 of 50 because it does not have a pair with the prime factors of 20. Step 3. List all the common prime factors of the numbers. The common prime factors are 2 and 5. Step 4. Get the product of the common factors. 2 times 5 is equal to 10. The greatest common factor or GCF is 10. The answer to the problem is 10 facts. The third method is the continuous division. Step 1. Arrange the numbers horizontally. 20, 15. Step 2. Think of a prime number that can divide both numbers. 2 is a prime number that can divide both 20 and 15. Step 3. Write the quotient below the dividends. 20 divided by 2 is 10. 50 divided by 2 is 25. Step 4. Continue the process until none of the numbers have common divisor. 5 is a prime number that can divide 10 and 25. 10 divided by 5 is 2. 25 divided by 5 is 5. The quotients are relatively prime. Therefore, 2 and 5 are our last quotients. Step 5. Multiply the common prime divisors. 2 times 5 is equal to 10. The greatest common factor or GCF is 10. The answer to the problem is 10 facts. As you can see, we arrive at the same answer using the three methods. Welcome back. This time, we will solve another word problem. Read with me. Andy visits the library every 6 days while Marco visits the same library every 9 days. If they are in the library today, after how many days will they be visiting the library at the same time again? Let us first analyze the problem. What is asked in the problem? The number of days they will be visiting the library at the same time again. What are the given? 6 days and 9 days. What is the strategy to be used? There are 3 methods to solve this problem. Let us start with the listing method. Step 1. List all the multiples of the numbers. 6. The multiples of 6 are 6, 12, 18, 24, and 30. 9. The multiples of 9 are 9, 18, 27, 36, and 45. Step 2. Identify the common multiples. We have 18 and 36. The common multiples are 18 and 36. If there is no common multiple on your list, you can continue listing the multiples of both numbers. Step 3. Identify the least common multiple among the common multiples. The common multiples are 18 and 36. So the least common multiple or LCM is 18. The answer to the problem is 18 days. Another method is the prime factorization. Let's use the factor 3. Step 1. Find a pair of factors whose product is the number we are factoring. For 6, we have 2 and 3. For 9, we have 3 and 3. Step 2. Continue factoring until the factors at the bottom of the tree are prime numbers. For 6, 2 and 3 are both prime numbers. So that it's the end of the factor 3. For 9, 3 is a prime number. So that is the end of our factor 3.
Step 3. List all the prime factors of the numbers. For 6, 2, and 3. For 9, 3, and 3.
Step 4. Multiply the common factors and the other prime numbers. The common factor is 3. The remaining prime factors are 2 and 3. Therefore, we have LCM is equal to 2 times 3 times 3. The least common multiple is equal to 18. The answer to the problem is 18 days. The last method for solving this problem is the continuous division. Step 1. Arrange the numbers horizontally. 6, 9. Step 2. Think of a prime number that can divide both numbers. 3 is a prime number that can divide both 6 and 9. Step 3, write the quotient before the dividends. 6 divided by 3 is 2. 9 divided by 3 is 3. Step 4, continue the process until none of the numbers have a common divisor. The quotients 2 and 3 are both prime numbers. Step 5, multiply the common divisors and the last quotient. Least common multiple is equal to 3 times 2 times 3. The LCM is equal to 18. The answer to the problem is 18 days. As you can see, we will arrive at the same answer using any of these three methods in finding the LCM and GCF. Now, let's sum up the lesson. GCF through listing method. Step 1, list all the factors of the numbers. Step 2, identify the common factors. And step 3, identify the greatest common factor among the common factors. LCM through listing method. Step 1, list the multiples of the numbers. Step 2, identify the common multiples. Step 3, identify the least common multiple among common multiples. Greatest common factor through prime factorization using factor 3. Step 1, find a pair of factors whose product is the number we are factoring. Step 2, continue factoring until all the factors at the bottom of the tree are prime numbers. Step 3, list all the prime factors of the numbers. Step 4, get the product of the common factors. Least common multiple through prime factorization using factor 3. Step 1, find a pair of factors whose product is the number we are factoring. Step 2, continue factoring until all the factors at the bottom of the tree are prime numbers. Step 3, list all the prime factors of the numbers. Step 4, multiply the common factors and the other prime numbers. Greatest common factor through continuous division. Step 1, arrange the numbers horizontally. Step 2, think of a prime number that can divide both numbers. Step 3, write the quotient below the dividends. Step 4, continue the process until none of the numbers have a common divisor. Step 5, multiply the common prime divisors. Least common multiple through continuous division. Step 1, arrange the numbers horizontally. Step 2, think of a prime number that can divide both numbers. Step 3, write the quotients below the dividends. Step 4, continue the process until none of the numbers have a common divisor. And step 5, multiply the common prime divisors and the last set of quotients. Now, let us have an activity. Using any of the three methods, find the greatest common factor and the least common multiple of the numbers below. Number 1, 15 and 16. And number 2, 12, 30, and 20. Let us check your work. For number 1, the greatest common factor is equal to 15, and the least common multiple is equal to 16. For number 2, the greatest common factor is 4, and the least common multiple is also 16. Very good. And that ends our lesson. Again, this is Diane Cabiltes. Thank you and keep safe, everyone.